The topic name is 3D modeling and D3T in world building. So the definition of this topic is building, developing, or constructing three-dimensional spaces and objects with the help of digitized data for better manipulation and usage of advanced technologies for efficiency in a digital environment. So this topic is divided into 6 categories, and each and every one of these categories is divided into subcategories to explain them more in detail. Now, what is a dimension? Let's start with the dimensions first. A dimension is a number of coordinates to specify a point within it. We use it to measure the sizes of objects. Three-dimensional space is a space within 3 dimensions, while a dimension is a measure of length in a given direction. 1D is a measure of one dimension, the x-line. 2D measures in 2, x and y. And 3D measures in 3 dimensions, x, y, and z. According to Britannica, they are called respectively line, plane, and space. Also length, width, and height. Even though the graphics in question can be in many dimensions, we still observe it through our monitors, which are giving us a 2D picture. We can't feel the depth like we do in real life, but it gives us an illusion. And through its illusion, we get that feeling of depth. When it comes to modeling, it is related to this topic by having a model for design or design model. Modeling is making a given design, while a design is planning an idea for creation. 3D modeling. According to the wiki, in 3D computer graphics, 3D modeling is the process of developing a mathematical coordinate-based representation of a surface of an object, inanimate or living, in 3 dimensions via specialized software by manipulating edges, vertices, and polygons in a simulated 3D space. So let's dissect that. Computer graphics is a field that deals with any graphical representation of a digital environment that has been created within the digital realm and with the help of computer technology. Graphics here can be anything visual. The 3D in question is the digital world having 3 dimensions, which means more depth and more computing power necessary to render it. Modeling just means creation of a design. And here comes the big one. But why is the sudden math here? Why the math? I hate to say it, but if it weren't for math and physics, computers would not be possible. Math forms the foundation of computer science, and physics provides principles regarding electronic components. In this context, it provides us a systematic and precise way to describe objects using coordinates within a math framework, where then it is being used to manipulate the looks of an object within their 3D realm. Specialized software is basically any tool that does the creation and editing of virtual models and such. Vertices are connection points. Edges are lines in between those connection points. And faces are the sides of the connection. The edges, vertices, and polygons are plain figures or simply shapes. All of this within a digital world. It works similarly when a sculptor carves a shape out of a given material, unlike real carving, which requires a mass and material of choice, tools, and a lot of skills. In 3D modeling, you can start with nothing, or in some cases, block. Then you keep remodeling that piece bit by bit in many shapes and sizes through many styles to get the wanted model or figure. There are numerous 3D modeling techniques. Its history not that far, but is rich. Comparably, 3D requires more computing power than 2D since it deals with another dimension, usually in the same detail. 3-dimensional models represent a physical body using a collection of points in 3D space connected by various geometric entities such as triangles, lines, curved surfaces, etc. Physical body is a collection of matter at a given space. It uses a set of points in 3D space connected by various types of shapes. The set of points are connections in between a set of individual points in space. There is no single source that has all the types listed. The types are, brace yourselves, solid, geometric modeling, solid geometry, primitive, polygonal, spline, rational B-spline, NURBS, surface, voxel, inside prism, kit bashing, constructive solid geometry, Boolean, point cloud, digital sculpting, parametric modeling, subdivision, generative design, additive manufacturing, kinetic, procedural, implicit, environmental, sketch-based, freeform, curve, volume, dynamic topology, metaballs, yes, that's how it's called, marching cubes, level set, isosurface extraction, displacement mapping, texture mapping, retopology, physically based modeling, fluid animation, particle, photogrammetry, digital terrain modeling, subdivision surfaces, voxelization, vector displacement, shape grammars, image-based modeling, skeletal animation, muscle simulation, biomimetic modeling, haptic modeling, inverse kinematics, keyframe animation, motion capture, real-time rendering, physically based rendering or PBR, shader programming, radiosity, ray tracing, path tracing, global illumination, volumetric rendering, point-based graphics, scanned 3D models, digital twins, multi-resolution modeling, shape interpolation, multiphysics simulation. That is all that I had compiled at this time. Now, we cannot continue modeling without the necessary tools. The tools are any software or app that lets you create and style the model. The most popular ones are Autodesk, the first ever 3D software was Sketchpad, the free and open source Blender, and of course dancing 3D modeling software like SFM, Source Filmmaker, and MMD, Miku Miku Dance. Others are ZBrush, Cinema 4D, Rhino, and Houdini. Let's do a brief history to summarize it. 1960. 3D modeling was coined by William Feather and Vern Hudson. It was used only for engineering purposes at that time. 1963, the first software for 3D rendering was released by Ivan Sutherland. 1968, the first 3D graphics company called Evans and Sutherland opened. 1970, Ivan Sutherland and David C. Evans started teaching the subject. 1974, Edwin Catmull pioneers texture mapping. 1975 comes Utah Teapot by Martin Newell, made with Bezier curves. 1980, 3D graphics stopped being an academic field. 1982, AutoCAD was released. And in the 90s, it went to overdrive. What we have today is because of all that. When 3D modeling was fresh, 3D models were turned to sprites, 2D, because the computers were not able to render it in real time. Thus, they used a less detailed version of the model. Now, D3T, what is that? That is just a short form for digitization, digitalization, digital transformation. Digitization is conversion of analog to digital, from real world to ones and zeros. Digitalization is both usage of digitized data and digital technologies. Digital transformation is upgrading the entire business and work model. Together, I like to call them D3T. Now, what is digitization? Digitization is basically turning real world to ones and zeros. This can include converting physical objects, documents, and images into digital data that can be stored, processed, and transmitted by electronic devices, making it possible for manipulation, archiving, reducing waste, faster and easier usage. Without converting to digital, we would not be able to manipulate data effectively and efficiently as we do today. Its relation to 3D modeling is through technologies used in conversion, where we scan the world around us and import it. There are many types of digitization technologies: 2D scanners, 3D scanners, audio, video, image digitization, and document digitization. These are digital technologies that digitize the environment. So in 2D scanning we have flatbed scanners, sheet-fed scanners, handheld scanners, and drum scanners. And 3D scanning, which we'll get in depth in time, there are laser scanners, structured light scanners, photogrammetry, contact scanners, time-of-flight, LiDAR, the most important one, CT, more topography, and infrared. Audio digitization is analog to digital converters, digital audio workstations, and field recorders. Video digitizations are video capture cards, digital camcorders, and frame grabbers. Image digitization, digital cameras, flatbed scanners, slide/negative scanners. Document digitization has optical character recognition (OCR), microfilm scanners, and book scanners. Digitalization refers to usage of digitized data and digital technologies. Digitalization turns existing analog functions and interactions into digital and combined, often includes the use of software, automation, data analytics, and digital platforms to streamline workflows. In 3D modeling, involves adopting digital tools and workflows to streamline the creation, editing, sharing of 3D models. This process includes using software, digital pens, tablets, cloud-based platforms to make the entire modeling workflow more efficient and accurate. 3D modeling becomes more flexible, collaborative, and accessible, enhances both the creative process and the final output. Digital transformation is an even bigger and more strategic concept. It's the complete overhaul and upgrade of a process. It fundamentally changes a process driven by integration of digital technologies into all aspects. It includes both digitizing and optimizing existing processes and also rethinking, reinventing business models, customer experiences, and value propositions. Digital transformation requires a cultural shift and includes individuals. For 3D modeling, it requires constant approaches to new technologies and methods of making models. Enhances automation and AI, cloud-based collaboration, and integration of digital tools. 3D scanning technologies, or 3D scanners, are devices that digitize the environment to create a digital 3D model. 3D scanning is analyzing an object to collect its 3D data in all three dimensions. The technologies are laser scanners, structured light scanners, photogrammetry, contact scanners, time-of-flight, LiDAR, CT, motor topography, and infrared. LiDAR. It stands for Light Detection and Ranging, or Laser Imaging, Detection and Ranging. Uses laser pulses to measure distances to a target, creating a detailed map of the environment, which can be scanned in a fixed position for images or scan multiple directions for 3D imagery. This scanner enhances augmented reality AR experiences and helps in 3D scanning by capturing depth information. Light scanners. They use various types of light to scan an object's surface and capture its geometry. The term light scanners is broad and can refer to any scanning technology that relies on light to capture 3D data. They can be used in long-range scanning, accurate for long distances, can be slower depending on the method, especially for high-resolution scans. Photogrammetry is a method of collecting information about the environment by recording, interpreting images. Basically means getting measures from photographs. It involves capturing multiple images of an object, structure, or landscape from different angles and then using software to analyze and reconstruct the 3D geometry of the subject or object. Particularly used in fields like architecture, archaeology, and gaming. Time-of-flight, TOF, is a measure of time taken by a particle to travel a distance through a medium. It also measures how long does it take for different things to travel on different paths and through what. It can be also used to study the mediums and particles that flow through it. TOF is used in magnetic resonance angiography. Structured light scanner projects a pattern, usually a grid or stripes, onto the object surface, captures the distortion of the pattern to create a 3D model. It's used for scanning objects with complex surfaces, offering high accuracy. Laser triangulation scanning. It uses a laser beam to scan across the object's surface. A sensor measures the angle of the reflected laser to calculate the distance to the object, creating a 3D model. It's called triangulation because the laser dot, camera, and laser emitter form a triangle. CT, or computer tomography, uses X-rays to take cross-sectional images or slices, which are also called tomographic images, of an object. Once enough slices have been collected, they can be turned into a 3D model. It shares the goal of creating detailed internal and external 3D models with other methods. Motor topography is used for the analysis of human body surface. Uses a pattern of light, often stripes, projected onto an object. The interference pattern, it's called the Moore effect, caused by overlapping patterns, is analyzed to create a 3D surface model. It was coined by H. Takasaki in the 70s. Infrared scanning uses a thermal imaging camera, infrared light, to scan objects, often used in mix with other scanning methods for enhanced detail or in low light conditions. It detects and estimates temperature from an object, All scanning methods use some form of light to scan objects. Contact-based scanning is the only method that's kinda invasive, that requires physically touching the object with a probe to measure points on its surface. It's used in precision engineering and quality control, especially for objects with very fine details. Virtual reality is a fully immersive experience, while augmented reality combines real-world and CGI 3D content. It is important to clarify that a virtual world is a place in the digital realm, a computer-simulated environment that can be accessed via a medium of communication. A virtual world is any representation created and accessed through electronic devices. Is not real in a physical sense, but relies on digital infrastructure for its existence. Virtual worlds provide ways of interaction that cannot be done in the real world, or as places of experimentation, immersion, and knowledge, where users can interact with each other and the environment itself. Virtuality can be achieved by replicating aspects of reality or creating entirely new digital realms. A virtual world can include, but not limited to, video games, software, audio, video, text, chat rooms, web pages, textual graphical interfaces, video avatars, and many more. 3D modeling creates interactive, immersive virtual worlds. It is very helpful to create and test something without spending much and without worrying about side effects. Everything is done in a secured environment, thus making virtual worlds a perfect encased testing ground. Virtual worlds have grown in popularity due to how versatile they become, offering a wide range of experiences from interaction, gaming, to education and remote work. To access one, you need an electronic device, usually being computers, laptops, smartphones, tablets, consoles, and etc. Computers offer the most processing power and higher quality experiences. Smartphones and tablets offer accessing on the go, consider it a pocket dimension. Laptops are in between the previous, they are semi-portable and medium strength. The software on the device, such as its operating systems and chat rooms, are virtual worlds too. Some virtual worlds can be accessed through web browsers without downloading extra software. Those usually are web-based platforms, websites, and so on. If you watch this video, they're probably on some web-based platform. So let's go further in the hardware section. VR, virtual reality headsets, they provide a fully immersive experiences surrounding the user with a 3D virtual environment. The most famous ones are Oculus Rift and HTC Vive. They offer interaction in a physically engaging way. In augmented reality, the content can span many senses. It can use specialized hardware, motion controllers, haptic gloves, or advanced input devices to interact with virtual worlds. Suit hardware for VR is also called haptic suit, VR suit, tactile suit, gaming suit, and in some cases Tesla suit. Other wearables and Internet of Things devices are smartwatches, smart glasses, in some cases smart contact lenses, and so on. They offer access to virtual worlds or enhance experiences. AI usage. When it comes to AI, it's an ever-growing and fast-paced field. It is of great benefit to have AI at your disposal, but not to over-depend on it. Nowadays, AI is simpler to use and navigate and gets the job done. In the art world, it should be used as a means of allocating time in creating the art rather than replacing the artist. It's important to add that AI can make mistakes, therefore it's good to have a relevant professional in that field for that region where the AI is used. In the 3D world, AI can create 3D model using photos or video snippets as reference. It can be precise depending on how specific we are using it. AI tools can predict and automate repetitive tasks. It needs to learn from existing data like movements to apply them. It can also predict and suggest animations based on the model's current state. Now, it cannot fully make an animation without mistakes, so I've found at least 5 problems AI currently faces. The training, which is the most important one. Complexity of the work, costs, overusage, devaluing of work. Challenges of AI can be mitigated with proper use and research. The benefits, they are accessibility, automation, efficiency, added creativity, which humans could not think of at that time or at all, and streamlining the process. Combining all the aforementioned topics, dimensions, modeling, 3D modeling, D3T and virtual worlds, including AI, we identify a sector that is not only standalone, but also a critical component across various industries. This sector is both artistic and scientific. Its growth relies on advancements in science and technology, while its application remains artistic. It provides a secure test model for nearly any field.